Hi all, welcome back. And today we are going to discuss about data types in pandas. As I have mentioned it multiple times, when you are going to read the real world data, it is going to be messy. For example, you are reading transaction based data and let's say the customer ID has been saved as a integer data type when you are reading the data. But we all know that customer ID cannot be an integer data type. It should be a string data type because we are not going to apply any mathematical operation or statistical analysis on that particular column. Similarly, let's say when you are reading that data, you have a date time field, but somehow it has been saved as an string data type. But ideally, it should be saved as a date time field. So that you can use various date time methods of pandas data frame effectively. Another major advantage of using data types correctly in pandas is that you can reduce the memory usage of pandas data frame, and that will help you to run various methods and functions of pandas quicker if the data type is chosen wisely. Before we start our discussion on the topic, I think it is very important information for beginners that Pandas is built on top of NumPy. Pandas uses its own native implementation of data structures such as Pandas series and data frame, but it most commonly used data types that have come from NumPy as well as the underlying algebra required for the matrix operation. That also comes from NumPy. Since that library implements efficient and fast Python code for performing matrix algebra operations, and that is why you will find a lot of data types in pandas data frame, or I can say that most of the data types in pandas data frame will come from NumPy. Now let's get back to the topic. Pandas store its data such that each column is exactly one data type. And if someone analyzes pandas data frame, one will find that these data types, the common data types in pandas data frame, they are going to appear more frequently in pandas data frame. And what are those? Integer, which are whole numbers; float, which are decimal numbers; object, which can be text, mixed, numeric and non-numeric values; boolean, date time delta, and category. So these are going to be the common data types in pandas data frame when you are reading a data set. Knowing the data type of each column of your pandas data frame is very important. Actually, it is one of the most fundamental piece of the knowledge of your data frame, and one of the main reasons for this is that every value in each column will be of the same data type as I had mentioned earlier. Now let's read the data and see the various type of the data types in pandas data frame. Now we are going to read our superstore dataset, which we are using in the previous videos also. And for this particular video, I have already written the code because I want to focus mainly on the data types. And now let's get started. I'm going to call the imported libraries, which are pandas and NumPy, and as well as I have also called warning library to ignore certain warnings if there are any. Then we are going to use a very naive method of using read underscore CSV, and we are going to call a superstore dataset. It's a Tableau superstore dataset, and you can get that particular dataset very easily by googling it. So we have read that particular dataset, and now we are going to inspect it. Let's see if there are any null values. There are certain null values in postal code. There are 11 null values. We are going to drop them. And by the way, do not worry about like what are the methods I'm using, whether to drop the missing values or reset the index and all those stuff. And by the way, we have already touched base on the topic how to inspect a data frame, and we have discussed about all these methods in the previous video, so you can watch that particular video if you are interested in. However, the main topic is data types, and we will focus on that. So what I'm doing here is I'm going to drop the missing values from our data frame. So there are total 9,994 records. Let's see that df.shape. So you can see here there are 9,994 records, and 20 columns. I'm going to drop 11 records and then I'm going to reset the index. We can verify that those 11 records have been out from a system, and there are 9,983 records now and 20 columns. Now let's see what are the data types in our data frame. So you can see here order ID has been saved as an object. Order date is also saved as an object. Ship date is saved as an object. Customer ID is saved as an object. Postal code is saved as a float 64. Product ID is saved as a object. Sales is saved as float 64. Quantity is saved as integer 64. Discount is saved as float 64. Profit is saved as float 64. And D types is, you can see here, float 64 has 4 columns, integer 64 has 1 column, and object has 15 columns. We can also use df.dtypes.value and accounts to get that particular information. Now let's use the head method to see how our data looks like. As you can see here, order date and ship date, they are saved as a object data type. Since it is saved as an object data type, we can not use various methods of datetime which are basically accessible for a datetime field. So we need to convert these particular columns as the datetime field to effectively use Pandas datetime functions. Similarly, postal code is saved as a float data type. It should not be saved as a float data type. Actually, it is an object data type. And it should be saved as an object data type because we are not going to apply any mathematical operation on postal code. Now you have seen here that while reading the Superstore dataset, we had faced certain problem with order date and ship date as well as with the postal code that they have not been read correctly. And we have seen that there are 15 columns with an object data type, which is basically used to store the string data types. For example, segment, which is a string data type, you can see here, country, again the string data type, city, county, region, and various other fields. Let's start discussing about the string data types. Basically in Pandas data frame, you can use 3 ways to save the text data type. First one is object, second one is category, and third one is string, which is an experimental in nature. Let me emphasize on the string data type. It is actually new to Pandas data frame. It came into the existence from the version 1.0 and it is still experimental in nature, and it is suggested that you do not use it for the serious work as its functionality may change. Until the release of Pandas 1.0, Pandas did not have a string only data type. Instead, it used the object data type to hold a string, which has come from NumPy. And as I had mentioned earlier, in the beginning of the session, the object data type has no limitation as to what Python object can be within it. Though the object data type may contain any Python object, it is primarily used to hold a string in Pandas. For example, segment, category, and subcategory are object data type. And when we verify this, you will see the output data type as O. The object data type also comes directly from NumPy, as I had mentioned earlier, and that uses the O to represent it of object data type. Let's see that. I'm using the head method again to show you how the data looks like. And do not worry about the code part. Here basically I am changing the data type of postal code from float to object data type. And do not worry about these code. We will discuss in detail how you can convert a Pandas data type variable. Let's run the code. We cannot interpret much, but you can see here it has been converted from a float to, it looks like an integer, but actually it is saved as an object data type. Let me verify that for you also. So you can see here postal code has been converted to an object data type because we are not going to apply any sort of the operations. any mathematical operation. Another major benefit that data frame with columns that has an object data types are designed to fill with strings and has an stressor, and it has various attributes and methods that are available for this data type, and we will discuss about the stressor in detail when we will talk about string functions later on. But let me give you a glimpse of how we can use it effectively. For example, let's say order ID, it has CA as a capital letters, right? We want to convert into a lower letter. So you can see here C has been converted from uppercase to a lowercase, CA, and then US. Now let's discuss about categorical data type. Categorical data type is unique to Pandas and it does not exist with NumPy. The categorical data type is often used whenever a column of a data has known, limited, and discrete values. Moreover, any column may be converted to the categorical data type, but most often it is a string column that are chosen. In Superstore dataset, let's see which string columns are a good candidate to be a categorical data type. Now, what we are going to do here is we are going to call all the object variables using select underscore dtypes method in Pandas data frame, and then we are going to use the chaining property of Pandas data frame and we are calling the nUnique method. So what does this function will do, that it is going to select all the object data types and it will provide us the information about the unique attributes of that particular variable. So let's run the code and see how many unique values are there in a particular object variable. So you can see here order ID is 5003, order date and ship date should be a datetime field, but they had been loaded as an object data type. Ship mode has 4 categories. Customer ID has 793, customer name, which is similar to customer ID, which is 793, segment 3, country 1, city 531, state 48, region 4, category 3, and subcategory 17, product name is 1848. Now let's discuss the properties that make a particular column a good candidate to convert to categorical data type. One of the property for a categorical data type is the total possible number of values in the column should be known. You can think of ship mode is not going to change very frequently. Segments are not going to change. Country is not going to change. States are not going to be changed. Regions are not going to be changed. Category not going to be changed. Subcategories are not going to be changed. Another thing which I'll suggest, whenever you are making a categorical data type, it is better if you talk to a stakeholders, whether some of the new categories can be added up or not and all this stuff. The reason is the second property for a categorical data type, if you are converting from object to categorical data type, that there should not be any mysterious value that will appear when future data of the same kind is collected. The value should be discrete, meaning there are no partial values, and the unique values in the column should be limited and far less than the total number of values. So what we can do here to calculate the percentage, we can use df.shape and use 0. It will give us the percentage, that what is the percentage of uniqueness in the in that particular variable is. So for example, it is very low, segment is very low, country is very low, city is very low, but we are not going to use city because maybe the company can expand into another city. States are going to remain the same, regions are going to remain the same, category and subcategory. So you can see here what I'm doing here, I'm converting all these objects data type into the categorical data type. So let's run this code and let's see whether they had been converted successfully or not. So info method is going to provide that information for us. So you can see here ship mode has been converted from object to category. So here you can see ship mode was object, everything was object. So we have converted ship mode to category, segment to category, country to category, state to category, region to category, category and subcategory to category data type. Now one thing you need to notice, that the memory usage of the data frame. If you will see here, the memory usage was 1.5 plus MB. Now once you have converted the object data type to category data type, it has reduced to 1.1 plus MB. Around 25 to 30% of the memory usage has come down. Now on the surface, our categorical series looks very similar to its object series counterpart, but there are some significant differences. Basically, categorical data is stored much more efficiently than the object data. And one of the reasons is object data has come from NumPy. And categorical data type is you can say native to Pandas data type. Moreover, each unique value in a column of categorical data is stored once, and regardless of how many times it repeats in the series or in a data frame, and each of the unique value has an integer code that refers to it. It is these integers that are stored in the memory to represent the data. There is another advantage of using categorical data type. Apart from having a str assessor, it also gets a cat assessor that provide us with special attributes and methods for categorical variables, and we will discuss about the cat assessor during the string manipulation session. Right now I just wanted to provide that what are the major advantages of using categorical data type. So category, which is now a category data type, and we can use the str assessor. You can see here, with the release of Pandas 1.0, a new Pandas only data type called string was made available. It can only contain strings and missing values, and again, as I had mentioned earlier, avoid using this data type for serious work until it is no longer experimental. Currently it is only experimental in nature, and I'll suggest you not to use it. So we have discussed three data types to store text in Pandas data frame. One is object, second one is categorical, and the third, which is experimental in nature, is string data type. Now let's discuss about the numerical data types in Pandas data frame. Let's use info method on our superstore dataset. You can see here sales is float 64, quantity is integer 64, discount and profits are float 64. Let's discuss quantity, that is integer 64 data type, which formally represents a 64-bit integer. This data type comes directly from NumPy, which allows integer to be either 8, 16, 32 or 64 bits in size. A 64 bits integer can contain up to 2 raised to power 64 power number of integer. What I mean to say is, see, I do not know how many numbers are there, more than trillion or so. The integer 64 data type has both positive and negative value. It means it is going to have plus minus this number of value. We can use a NumPy function that has an integer info method that returns the exact integer information for each data type. For example, we can use np.info method, and if we will pass here int 64 data type, oh sorry, my bad. You can see this is similar to what we have got here. Similarly, if you want to get the information about, let's say, int 16, this is the minimum number of the values and this is the maximum number of the values you can have. The one thing which to be noted, that default data type of Pandas data frame is dependent on the platform that you are using. For 32-bit machine, it means that integer will be 32 bits by default, whereas for 64 bits machine, it will be 64 bits default. For example, if it is integer data type, then it is going to be the integer 64 data type. By default, it is going to be there when you are loading up the data. Now you have seen here the quantities in our data set. Let's say quantity min and max. Is 1 and 14. Let's see what is the min and max value we can have for 8 is minus 128 to 127. We had seen it has not gone beyond 14 quantity. What we can do here, we can change the data type of quantity to integer 8, and then we will see the memory usage. Let me put up the memory usage function here. So you can see here the memory usage of quantity is 79,864 bit. Let's say if we convert it to integer 8, then what is going to be the memory usage for quantity? Now you can see here, once we have converted our quantity data type from integer 64, which is by default, to integer 8, the memory usage for quantity has reduced drastically from 79,864 bits to 9,983 bits. So if you will use your data type wisely, you can significantly reduce the memory usage. And if the memory usage will be low for your data frame, then the code will run faster. Now there are some other data types also. I'm talking about the integer data types. They are the unsigned integers. The default integer data type is split half of their range between negative and positive integer. There can be a case, for example, in superstate data set, variable quantity can be non-negative integer. By using the unsigned integer data type, we can further reduce its memory usage. For example, if I change it to by passing u int 8, in this particular case it has not made any changes, but generally if you will use ui int 8, it will reduce the memory usage for that particular variable also. And by the way, it is very rare to use unsigned integers, but they are available and can be useful in a specific situation where you would like to save memory. Now let's discuss about another numerical data type, which is float. In our superstore data set, we have sales, discount and profit, which are float data type. Float column contains number with decimal places. The default float size for all platform is 64 bits, and all float data types can contain missing values. Let's see info of float variable using finfo method in NumPy, and it is very high. I do not know what is how to interpret this these numbers, but they are the huge numbers, and anything can be saved as a float. Now, just like integer, we have different options for float also. For example, 32, it will reduce the memory usage significantly. If you are using, let's say 16, then again you can see here this is the min and max value. So basically depending upon the min and max value of a particular numerical data type, you can use what is the correct bit size for the float data type for that numerical variable should be. So that is all about numerical data types, and one can save a numerical variables either as integer or a float. Now let's discuss the Boolean data type. Booleans have a single 8-bit data type, and it makes sense because Boolean data type has only two values such as true and false, 1 and 0. There is an interesting property of Boolean data type that it is possible to convert integer and float columns to Boolean and vice versa. Right now in this particular superstore data set, we do not have any column as such, and it is pretty much straightforward that what Boolean data types is, and we will be seeing some of the examples later on when we are going to do the data analysis of superstore data set. Now let's discuss about the date time data types. Now, if I'm going to get into the detail, which we will sure get into the detail of date time when we will be doing the time series analysis of superstore dataset. But right now, if I'll go into the detail, it might take another 1 hour. However, I will give you a brief about the three options which are available in Pandas data frame. One is date time. So date time data type is basically a single moment in either in a time or a day. It contains both a date, which is year, month and day, and a time, which is hour, month and second component. For example, July 7, 1981. For time delta, which is another data type in Pandas data frame, is an amount of time. It has units of days, hours, minutes, seconds and part of a second. It is not attached to any date. For example, 5 hours 34 minutes. And the third data type is period, which is basically a span of time. There is a start and end of a period. The units basically depend upon the length of the time period. For example, between July 7, 1981, which is the start time, and then let's say February 14, 1982 at midnight. So that is an end time, and that is going to be the span basically. There is one thing which I would like to mention. It has a DTSSR and it has lot of wonderful methods in Pandas data frame. As I had mentioned earlier, that ship date and order date are saved as an object data type. In the next session, anyways, we are going to discuss in detail that how could you convert a data type in Pandas data frame. But here I'm just showing you that ideally order date and ship date should be saved as a date time field. And by using select underscore d types method, when I passed date time, it has successfully presented order date and ship date here. And if I rerun this code info method, you can see here order date and ship date has been converted to date time 64. So today we have discussed in detail what are the common data types available in Pandas data frame. And in the next session, we are going to discuss about how to convert the data types in Pandas. Till then, goodbye and take care.